So for Unit 5, very first thing that we're going to be doing is simplifying rational expressions, which means we're not solving. All we are doing is simplifying. So what is a rational expression? A rational expression is an expression that can be written in the form polynomial over polynomial. So it is a fraction. What does poly mean? Poly? Mono means one. Poly means two. More than. Bi means two. More than one. Poly means more than one or many. So remember, that's like something with more than one term in it. So it's going to look very similar to the problems that we did in the pre-assessment yesterday. Okay, we're actually going to start being able to learn how to do these. So you are going to have fractions. And in the fractions are not going to be just numbers anymore. You're going to see actual expressions in there. Okay, now because we are working with fractions, there's one important rule that we've used since elementary school about fractions, and it has to do with the denominator. Does anybody remember what it is? Christina? Denominators have to be the same. That's what for when we're adding or subtracting. I'm just talking about if I give you a fraction, there is one thing that can never ever be in the denominator. Do you remember, Genevieve? You can have a negative in the denominator. That's okay. 0. Okay, so write that note. The denominator cannot be 0. Why? If I give you a number over 0, what does that come out to? Nothing. We call it undefined. Okay, so if you have a 0 on top, that's okay. Your answer comes out to 0. If you have 0 on bottom, it's nothing. It's called undefined. So we need to just make sure that we are aware in future references that the denominator can never be 0. So we need to know what steps there are in simplifying these rational expressions. The first step is you're going to factor the denominator, or the numerator, and the denominator. So you're going to be able to factor these things. So you want to factor the numerator, which is the top, and the denominator, which is the bottom of the fraction. You might be able to cancel some terms, so you're going to cancel terms that you can. And then after you cancel any possible terms, last thing you're going to do is simplify. One more definition. We have something called opposite factors. Opposite factors is a subtraction-only problem in which two numbers in the binomial are switched. So for example, I have x minus 3 and 3 minus x. These are very similar problems, but remember, order matters when we're dealing with subtraction. So these are called opposite factors because the x and the 3 are flip-flopped in both of these. Okay? It must be, it's only with subtraction because order matters with subtraction. So how do I simplify using these opposite factors? What we're going to do is we're going to factor out a negative 1 from one of the factors, and that's going to help us in simplifying. So what does this look like? I'm going to use this example, the x minus 3. So we have 3 minus x here. That looks very similar to x minus 3, but they're not exactly the same because these two things are flip-flopped. Now, we are not allowed to just move them around because it's subtraction and order matters. So our instructions say to factor out a negative 1. So if I factor out a negative 1, that means I'm dividing each term by negative 1. So 3 divided by negative 1, what does that give me? Negative 3. Negative x divided by negative 1, what does that give me? Positive x. So now I have negative 1 times negative 3 plus x. And with addition, can I flip-flop things around? Yeah, so this is the same as negative, because remember I don't have to write the negative 1, right? X minus 3. Now does it look like the other one? Yeah, the only thing that's different is the negative. That's why these are called opposite factors, because one is addition and one is positive and one is negative. We are going to be using this in some examples today. So you guys ready for an example? Alright, example 1. We have 10x plus 5 all over 20. Okay, so I'm going to go back to my steps really quick on how to simplify. Step number 1 says to factor the numerator and denominator. So I'm looking at this problem, and I'm thinking I can factor the numerator. What method will I use to factor the numerator? Good, GCF. Okay, so now I have to figure out what the GCF is. I have a 10 and a 5. What would be the greatest common factor of those two? Good, 5. So factor out a 5. That's going to leave me with 2x plus 5 divided by 5 gives me 1. So remember that 5 does not go away. It turns into a 1. All over 20 is just a number. I can't factor that. Now, step 2 says to cancel any terms that I can. Looking here, I don't see anything that cancels, but when I go to step 3, simplify, I see some reducing that I could do. Do you guys see any reducing? Yeah, what do you see? 5 and 20. How many times does 5 go into 5? Once. How many times does 5 go into 20? 4 times. So that's going to give me 2x plus 1 all over 4. Now here's a mistake that I see very commonly. A lot of students see that we have a 2x over a 4 and they want to reduce those two things. 2x plus 1, remember, is actually in parentheses, which means it has to stick together. Okay, because they're being added to each other, it's kind of like glue. You can't reduce part of it and not reduce the other part. So even though 2x over 4 does reduce, 1 over 4 does not. So we can't reduce anything here. So our answer is going to be 2x plus 1 over 4. You don't have to write the parentheses. You can if it will help you to remember to keep it all together. I typically don't, but you can if you want to. But let's write ourselves a note too. Do not reduce when there is a addition or subtraction. So you can only reduce if everything is attached by multiplication. If they are attached by addition or subtraction, you cannot reduce them because you can't reduce part of it and not the other part. Example 2, we have 2p minus 24 over 4p minus 48. Step 1 was to factor the numerator and the denominator. What method, I'm going to pull a stick, will I use to factor the numerator? Who's 16? Sure, what method will I use to factor the numerator? Yeah, GCF. What is the GCF? 2, good. So we have 2 times p minus 12. What method will I use to factor the denominator? Who's 20? Kyle, what method will I use to factor the denominator? Also GCF. What is the GCF? Good, 4. So that's going to give me p minus 12 as well. So we have 2 times p minus 12 over 4 times p minus 12. Now step 2 said that I need to cancel whatever I can. Do you guys see anything that will cancel? What? Yeah, p minus 12 is in parentheses, right? So that means it has to stay together. But what do you notice? I have a p minus 12 on top and a p minus 12 on bottom. So can I cancel those? Yes, I can. So cancel those two things. So that's going to leave me with 2 over 4. It does reduce. What does 2 over 4 reduce to? Very good, 1/2. Example 3, I have 2b minus 8 over b squared minus 16. step 1 is I want to factor the numerator and denominator. What method will I use to factor the numerator? Good. What is the GCF, ladies and gentlemen? 2. So that's going to be 2 times b minus 4. Okay, what about the denominator? Yeah, it's a difference of 2 squares. So how does that factor? b plus 4 times b minus 4. Step 2. Cancel what I can. Do you guys see anything that cancels? Good. B minus 4. So what am I left with? 2 over b plus 4. Can I reduce the 2 and the 4? No, because they are connected by addition. So I'm going to leave my answer as 2 over b plus 4. All right, example 4, we have m squared plus 7m plus 12 over m squared plus 6m plus 8. Okay, ladies and gentlemen, we need to factor these things. What method does the numerator look like? Diamond method. It was actually in our AO, right? What two numbers multiply to 12 and add up to 7? 4 and 3. Good. So this is going to give me m plus 4 times m plus 3. Denominator is also diamond method. What two numbers multiply to 8 and add up to 6? Thank you, Marcus. 2 and 4. So that is going to be m plus 2 times m plus 4. Does anybody see something that cancels? M plus 4 and m plus 4. So that's going to give me m plus 3 over m plus 2. I cannot simplify anymore, so that's my answer. Okay, remember, the m's do not cancel because it is all addition. They're connected in parentheses. So unless they are exactly the same, you cannot cancel them. Okay? Thumbs up, thumbs down now. Excellent. Good. Okay, example 5. 5 minus 4n over 4n minus 5. Okay, guys, what do you notice about this? They're the same but opposite. So what did my instructions say I had to do? Factor out a what? A -1. It does not matter which one you factor out a -1 from. I usually prefer to have my variables in front, so I typically go with the one that has the variable in back. Okay, so if I factor out a -1 from the numerator, I can just write it as a negative, right? And then after I factored out the -1, what happened to both of those things? They flip-flop, right? So we can, after we factor out the negative, we can flip-flop these to become 4n minus 5. All over 4n minus 5. Now remember, this 4n minus 5 is also in parentheses. You just don't have to write it. And do you see anything that cancels? Everything except the -1. So what's my answer? -1. Okay, example 6. 4m minus 8 over 4 minus 2m. Step 1 is we want to factor the numerator and denominator. What method will I use to factor the numerator? GCF. What is the GCF?
4.
Good, 4. So factor out a 4. So that's going to give me m minus 2 over. Remember, 8 divided by 4 gives me 2. Yeah. What's the GCF of the denominator? 2. So that's going to be 2 times 2 minus m. What do you notice? These are opposites, so we can factor out a negative. Like I said, I always use the one where the variable is in the back. So if I factor out a -1 from this guy, what happens to that 2?
The 2 negative.
It becomes a negative 2. So that's negative 2. And then what happens to both of these? They flip. So this becomes m minus 2. Does anything cancel yet?
M minus 2.
Good. M minus 2's. So that's going to give me 4 over negative 2. Does that reduce? Yeah, what's 4 divided by negative 2? Negative 2. Remember, this does also reduce to 2 over negative 1, but we never want to write the 1 on the bottom, so it just reduces to negative 2. Let's look at another one, example 7. 12 minus 4t over t squared minus 2t minus 3. Okay, numerator. How do I factor the numerator? GCF. GCF is 4, so factor out the 4. And that's going to leave you with 4 times 3 minus t over. What method will you use in the denominator? Diamond method. Good. So that's two numbers that multiply to negative 3 and add up to negative 2. 3 and 1, and which one has to be negative? The 3. So this is going to be t minus 3 times t plus 1. Now what do you see? The opposite. So let's do it with the numerator. So I need to factor out a negative 1, so that's going to turn 4 into negative 4. And this changes to t minus 3, so we can flip them. So that's going to give me negative 4 times t minus 3 over t minus 3 times t plus 1. And then what can I do? Cancel the t minus 3's. So that's going to leave me with negative 4 over t plus 1. So, example 8, last one. We have 16 plus 16m plus 3m squared over m squared minus 3m minus 28. Okay, something I noticed about the numerator, it doesn't quite look right. What's wrong here?
The 3m squared.
Yeah, that 3m squared is in the back and it should be in the front. So we can reorder them. That's okay. So let's reorder it first. 3m squared plus 16m plus 16 all over m squared minus 3m minus 28. So all I did was reorder it. So now I have to factor the numerator and the denominator. Look at the numerator, guys. What method is that? It's bottoms up. So what's the first step of bottoms up?
3 times that.
Yeah, multiply the 3 times 16. So in the numerator, I'm going to get m squared plus 16m plus 48. All over, what method will I use in the denominator? Diamond. So what two numbers multiply to negative 28 and add up to negative 3? Marcus? Good. Negative 7, positive 4. So the denominator factors to m minus 7 times m plus 4. Now obviously we're not done, right? Because we are still doing bottoms up on the numerator. What do I do next in bottoms up? Good, diamond. So two numbers that multiply to 48 and add up to 16. Thank you. So that is m plus 12 times m plus 4 all over m minus 7 times m plus 4. Now a lot of you are about to get really excited because you see m plus 4 and m plus 4, but what method am I doing in the numerator? Bottoms up. So am I done with bottoms up? No. What do I have to do next?
That's so exciting. Divide by
Yeah,
3.
I have to divide by 3 first. 12 over 3, how does that reduce? To 4 over 1. Does 4 over 3 reduce? No, so you get to bring it up. So this all comes out to m plus 4 times 3m plus 4 over m minus 7 times m plus 4.
The m and 4 are there.
Now m plus 4 and m plus 4 can cancel. So what is my answer? Good. 3m plus 4 over 3m minus 7. Can I reduce the m's?
No.
No, because it's all addition and subtraction. They are stuck together. That is simplifying.